Well, boys and girls, welcome back to Munro Live Podcast. And I'm here with Sue and Eric, and they're from Exro. And Exro is kind of producing some magic that I need to know a lot more about. We have many customers that are in the business of getting inverters and whatnot. Yours has some very unique sort of characteristics. So this is Sue and Eric, and I would like to maybe have them introduce themselves. So Sue, could you kick it off?
Yeah, thank you very much, Sandy, and thank you for having us today. We really appreciate it.
Yeah.
I'm Sue Ozdemir. I'm the CEO of Exro. I joined in late 2019, and I actually come at it from the motor side of the business. So I grew up in an electric motor repair shop. My parents taught me how to fix a motor when I was really young. And the fundamentals of what we do is based on the physics of electric motors. I spent 9 years at GE, and Exro recruited me to join them in 2019.
What did you do at GE? Were you at the jet engine company or the electric motor company?
I was the CEO of GE Industrial Motors, so I ran their motor division. I was part of power conversion.
Excellent.
Mm-hmm.
All right, yeah, and my name's Eric Hustedt, the CTO here at Exro. And I guess my background is fundamentally in power electronics. So from a very young age, actually, I've sort of got fascinated with any electronics that requires mechanical design, right? So plumbing. Anytime you've got current going through some serious conductor sizes. So there was always I've had a fascination with mechanical engineering and electrical engineering. So those two kind of come together quite nicely with power electronics. And then joined Exro, almost 4 years ago now?
Yeah, May.
So before that, I was doing automotive power electronics with a company that originally started as International Rectifier, and then we went through a bunch of acquisitions and mergers and so on and so forth. But basically inverters with IGBTs and then silicon carbide, starter generators, power modules, that sort of stuff. So, and then last couple of years with Exro, working on the coil driver, and we don't do magic. It's all based on real physics.
Well, it's magic to me. Yeah. So there you are. Give us a little bit of background. You can. One of the things that I'm really the most interested in is how you can. I don't know the right terminology, but how you can get the best of both worlds out of an electric motor. When I saw the graph, I was pretty surprised. I'd never seen one like that before. So traditional torque chart versus a coil driver torque chart is the one that I kind of like. I'd like to see if we can talk a little bit about how that works.
Right. And so I'll go ahead and start with easy layman version, and then I'll let Eric give the real power electronics deeper dive. So generally speaking, we take the physics of electric motors called coil switching, which I'm sure you've heard of, into the electronics. So we're essentially electronically gearing. And so the advantage is really that you're able to get that speed and torque at the same time efficiently. So you're going to be able to climb a hill, or you're going to be able to cruise down the highway at full speed without the same drain on your battery that a standard three-phase drive would do. And so we look at it as the next generation platform of control, essentially replacing a three-phase drive with Exro coil driver inverters in mobility. Mm-hmm. Now, Eric, keep it not too technical, but try to tell us why we were able to do what we were able to do.
Yeah, so the two torque curves that you're seeing there, right? Like that's you can achieve that just by changing the number of turns on the motor, which is really all the coil driver does. I mean, so we switch the windings between series and parallel. So what that's essentially doing is changing the number of turns the machine has by a factor of 2. So, you might have, say, 12 turns in series, and you end up with 6 turns total in parallel. And so what that basically does is that when you're in series mode, you've got the inverter current flowing through 12 turns, which generates a lot more ampere turns, which is ultimately what makes torque in a machine. The problem that comes with that also is each one of those turns is producing voltage as the machine is rotating, which means that extra torque production stops pretty quickly because you run out of voltage. Then parallel mode allows us to, it cuts the torque in half essentially, but also it cuts the voltage the machine is producing in half, which allows the thing to spin to a much higher RPM before we need to do the thing called field weakening, right? Which is where we have to add D-axis current to start suppressing the internal field of the motor if it's a permanent magnet machine.
So maybe help Sandy to kind of see how that would apply in the real world, like how that would apply, like give the example of like if an electric truck, if a UPS truck is using our tech, how is the tech help better than what's in the market today?
Yeah, so what it does, I mean, electric machines can, they can obviously spin over a very wide RPM range, but to do that efficiently, you start getting into issues of matching the turns to the right operating region. So what the coil driver does is, I mean, that's what ultimately Exro the name Exro started as, is extreme rotation. So what this coil switching does is essentially it gives you, electric gearing is one way to look at it. From an electronics point of view, maybe impedance matching is a better way of looking at it, right? Because the impedance that the system produces at a higher RPM is very different from the impedance at a low RPM, analogous to gearing, because that's essentially the same impact, but in a mechanical sense. So all it's really doing is it's matching the electrical characteristic of the machine much better to the operating region that the machine is operating in at that instant. So if you're at high speed, you're in parallel, you don't have a lot of D-axis current, you're very efficient at that point. Whereas if we don't do the coil switching, to run at high speed, you have to have a lot of field weakening, which starts, taking away efficiency because you're putting current in the machine that's producing heat, but it's not producing torque.
Yeah. So at the end of the day, I one of the things that I also saw in there was that you can actually go from neodymium magnets down to maybe ferrite. Is that correct?
Yeah. So it's one of the things that I'm sort of most interested in, actually, is because I've grown to hate magnets.
Magnets are our friends.
Well,
anyway, go ahead. I'm just jerking you around, but I mean, there's a lot of people that have given ferrite magnets, the heave ho, and said, we just can't make anything happen here. If you could make that happen, the price of the magnet plummets. Doesn't drop, it plummets. So
yeah,
I'm kind of interested.
We have a study that we've done recently in collaboration with AVL, where a leading EV, and we put our coil driver, we gave all the information to AVL, and AVL put our coil driver into that vehicle, and we showed that we could reduce the magnet utilization by over 19%. And then, we could use
that's rare earth magnet, right? But I mean, if we were talking about ferrites, and this is actually, I mean, without pictures, it's a little bit hard to show, but a lot of these magnet-free or rare earth-free machines, they struggle to give you the performance over the full operating speed range. Is fundamentally the issue, right? So you can get the torque out of them, no worries, at low speed, but then they just fall on their face as the RPMs climb. And that's where the coil switching actually, in this case, electric gearing is the interesting one, is because we can bring that power back at high speed. So ferrite is very interesting. Induction for me is also very interesting because, I mean, the induction machine, it has a lot of safety benefits. So one of the big problems that you have with permanent magnet motors is, and whether it's ferrite or neodymium or whatever the case may be, if you spin that shaft, you've got it producing voltage. And if the drive shuts down or something happens with the vehicle rotate, or you want to tow the car, right? You have this rotating machine producing voltage that you have to manage. Whereas with an induction motor, for example, if it's not energized, it's just a rotating piece of steel and nothing happens. So, but yeah, no, the coil switching allows the magnet-free or rare earth-free machines to really give neodymium a good run for its money.
So you mentioned I didn't see anything here about induction motors, but are you saying that maybe you could eliminate magnets entirely? Because I'm also a big fan of induction motors rather than conventional PM motors. So I'd like to hear more about that. I did not see this, and I didn't see anything in the stuff that was given to me.
We're keeping that one under the radar a little bit, but.
Can't believe it. Oh man, I thought we were buddies.
Oh, sorry, man. But yeah, no. So induction machines have the same issue with field weakening. They perform very well, right? You can get the same, very similar torque density as a permanent magnet motor. The other cool thing about induction machines is they're very efficient at high speed.
Yes.
So the coil driver basically counteracts the problem that induction machines have, which is you can either make them run at high speed or you can make them run at low speed, but not both very easily. And having the 2-to-1 turns ratio essentially on that machine, because an induction motor is at the end of the day a rotating transformer. It brings back that power, and so we've got simulations and curves that basically, in my mind, the induction machine with a coil driver will beat an IPM.
It was kind of a natural progression, I think, an evolution of the tech, as that we started with IPM because that's what the majority of the industry is using. There's not a lot of favoritism towards induction because it can't do the performance that it's supposed to do. But like you, I grew up on induction motors, so I'm also a big induction motor. And so as Eric kind of really progressed and the coil driver evolved, then as he started working with different machines, induction became one of the ones that we've been working with in the last kind of several months. And the more we worked with it, the more we saw it really is a great platform for the coil driver. Yeah. And so we've got lots of simulations, lots of support on it. We're starting to talk to customers about how we co-develop, how we do something like that. But I'm glad to hear you're an induction motor fan too.
Well, I am, and quite frankly, it's because I'm really kind of interested in getting the price of EVs down, and induction motors, unless you're gonna machine copper, like you said, what was it, the very prominent electric car company, whatever, they also made an induction motor, but they had machined copper plates, basically like laminates. But anyway, I couldn't understand that one. But if you die cast aluminum straight into it, you've got this is lighter, which is one of the things I'm trying to do with every car every vehicle we try and design or what have you. We try and make it as light as we possibly can, and I just think that ultimately, if somebody can come up with some way of giving me what I can get out of a PM motor, then I'd have my customers switching in a heartbeat.
Yeah, no, you did the copper cage is what you're talking about, right? So the element. Yeah. Now so we're. I don't know if we're allowed to talk about the prototype.
You can talk about it.
Okay, yeah. So I've been doing a lot of simulation on induction machines. So we use ANSYS package. So I don't try to lie to myself with simulation. The idea is to get it as accurate as possible. But so we've just built a prototype, and it is a copper rotor. So the key thing with the aluminium and the cage is it's essentially acting as a conductor in there, right? So you want actually the copper has much lower conduction losses than aluminium does. So this is a copper rotor machine, but you can die cast the copper in there as well. So that's one of the things we're talking with some casting companies, and they will high pressure die cast the copper cage into the rotor structure. Yeah. So, but that increases the efficiency significantly, right? Because copper is about half the conduction loss of aluminium. Right. So, but yeah, no, that's I would love to do the same thing. To me, after doing all these simulations with a coil driver and what it does with series and parallel mode with an induction machine, the conclusion I'm coming to is like we can beat an IPM with a 3-phase with an induction motor, and then you have all the safety benefits. You can tow, you can drive that. We can coast the drive, right? Something you can't do with an IPM is if you're driving down the road at a certain speed and you want to coast down a hill, if you can shut the drive off, and you don't have any energy loss in the power electronics. Whereas with a permanent magnet motor, you have to maintain current flow in the stator, otherwise it basically blows itself to pieces.
Well, the other thing that I saw was that that you can extend life of batteries, or at least make a battery that might be running at 80%, bump up to 85 or maybe even 90% back. Is that, did I read that correctly?
You read that quickly. So that's a separate piece of technology for us. So we have 2 core technologies. The first one is the coil driver, which is motor control in traction inverters vehicles. The second one is a cell driver, which is battery level control. We haven't done it in a vehicle right now, but what we have proven is the ability to take a battery out of a vehicle and repurpose it, mix chemistries within one single energy storage unit. So extending the life. Theoretically, again, in simulations, we can see that we could use it in a vehicle and we could extend the life of the battery. We're not sure yet of the cost points of that, if that's going to help to reduce the cost of the EV, because like you, we believe that that's a key part of, making EV stick and transition and grow in numbers, is getting that cost down.
Yeah, well, the cost is the big thing. Batteries are the single biggest cost associated with any vehicle. And a lot of people are always worried about, which is, I think, baloney. I have a lot of problems with what I read in the paper, usually written by people who haven't a clue. But I really and truly believe that if there's some way that we could cut down the amount of loss that might come to batteries, especially with abuse. I mean, some guy was on one of the YouTube, or maybe it was X or something. I can't remember what it was. But anyways, he said that, he's got 110,000 miles on his battery or something along that line. And now the damn thing's dead. And then you read what kind of duty cycle he gave it, supercharging twice a day and then plugging it in at home on top of it. Oh my God. I mean, and cycling it from 0 to 100% continuously. I can blow up, in fact, I used to work for Ford, and we used to blow up engines all the time. And you can do it in a lot of different ways. Don't change the oil, or don't put oil in it, or get rid of the coolant. I mean, people can blow up an engine, and you can basically kill a battery as well if you do goofy things. Could your proposal with the new battery controller, could that maybe alleviate the problem, or at least circumvent someone who doesn't know what they're doing from causing serious grief to their battery packs?
Unfortunately, what's that saying is, you make something idiot-proof, the world comes up with a better idiot.
Yeah, exactly. Mm-hmm.
So
we're not supposed to use the word idiot anymore, but I use it all the time. I personally am glad that you said it first and I did not say it, because I have to continuously check myself.
Yeah.
I would say that I agree with you 100%. Part of the biggest problem is just education, and that, all we can do is be an advocate and be leaders in spreading education. Our control is like a next generation for battery management. So it's like battery control. It goes to the cell level. So you could predict sooner the problems that you're causing for your battery. But if they continue to do those unintelligent things to the battery, it's still
unintelligent. I'm going to write that down.
Taking notes. It comes down to why most battery packs, they have a large number of cells in series, right? So you end up with basically the weakest link being the downfall of the whole system. So
right. Yeah.
Our system will prevent the weakest cells from being overcharged or over discharged, which would eventually result in that pack lasting a little bit longer. But if you're fast charging, that's just hard on the battery. Fast charging, especially, a lot of cells, if you look at them, you can discharge them pretty quickly, no problem, like 10C, 20C, 30C. But it's the charging rate is typically quite sensitive in cells. So where our system does come into play is it allows you to take cells out that are being pressed a little bit hard maybe, and then let the rest of the system continue charging. Without going into too much detail, but it's fundamentally that's the whole ECS was designed originally with second life batteries in mind, where you have no guarantee what individual cell capacity is, right? So you've got a huge range of cell capacities, and that's why you can't put them into a traditional sort of series string, because you've got some cells are very weak and some cells are very strong, and you can never get full capacity out of the whole thing. Whereas our algorithm and our system allows us to put, we can put different cells of different capacities, different chemistries. They can all mix together and play in one system. They all get managed individually. So very powerful from that perspective.
Do you have to add any more sensors, or can you pick it up from, I don't know, impedance or whatever that comes through the signal, or how do you do that?
Well, I mean, we measure each cell individually. So, I mean, like a normal BMS does that anyway. You'll measure each cell voltage,
Yeah.
and I mean, the current is easy. You only have to measure that once because it's the same current going through all the cells. And then we'll typically also have some temperature sensor on the individual cells as well. But the secret is really in the cell switching and the algorithm that controls it. So from a second life battery perspective, it works for grid scale storage. So we can take used batteries and maximize their full capacity in a stationary energy storage application. And then for where we've sort of thought about it from an EV perspective, where it gets really interesting is when you combine fuel cell, which is a variable output voltage device,
right?
Needs a huge DC-DC converter. So we can kind of put a fuel cell with a battery system with our coil driver, because those things all sort of. So the coil driver right now we're using it at a fixed voltage, right? So normal, typical fixed DC link. Then you get those two torque curves. But the other alternative that you can use other way that you can use the coil driver is if you wanted to, say, for example, a direct fuel cell powered system, let's say a train, right? Where you don't want a battery in there and you've just got the output from the fuel cell coming directly into the traction inverter. Now, the voltage of the fuel cell is changing quite a lot with load. So you might be, 900 volts with no load, and it might drop to about 500 volts under full load. So now instead of using the coil switching to give you those two speed torque curves, and what you'll use the coil switching for is now to actually counteract the changing voltage of the DC link to maintain performance of the system. So we can almost make the varying DC link transparent to the motor performance if you're using a direct fuel cell conversion. Or in between, we can add the BCS to it. There's a whole kaleidoscope of ways you can run the fuel cell. You can fuel cell to charge a battery, or you can the full power. I mean,
it's kind of one of the big strengths of doing it through power electronics versus doing it only through a motor, evolution.
Yeah.
Battery evolution is that through the electronics you have a lot more choices of what you can control.
So have you ever talked to Nicola about this, the truck company?
I'm not going to answer who we talk to outside of public, because we are public.
Oh, all right. Well, if that's the case. Okay, so anyway, what's that?
We are in Arizona.
Well, I actually, we've worked with them in the past, and quite frankly, I'm a fan of fuel cells, somewhat. I do not believe that a fuel cell in a car is a good idea. I took apart the Mirai, and anyhow, I just don't think that's a good idea. I think that the first application that you could have that really makes sense is a Class 8 truck, and then from there it goes to the moon, literally. And that's where I think fuel cells will really, if they're bigger or they're in a situation where you have to carry tremendous amounts of power along with you, like hydrogen, then it's lighter and it's more cost effective and whatever. But controlling it under a variety of different circumstances, like you were just talking about, where you're climbing a hill versus just trying to get from point A to point B, that's where it could use some help. So, and I'm always looking for, again, they may not be customers, but I'm always looking for ways that we can help whomever happens to be in the EV world, help them to reduce cost, reduce weight, and ultimately give longer lives. So that's I'm hoping there's going to be a few people. In fact, I might encourage a couple of my contacts to have a look at this. Yeah,
and definitely those are kind of the core value props of using the coil driver in particular. Is that, you can reduce system weight because you use a smaller motor or eliminate a gearbox or an onboard charger. Yeah. And then you drive down cost from doing it through the electronics as a system.
Well, there's a couple of you've got a couple of examples in your in your portfolio that I got. Can you maybe address a couple of the? I'm not sure if they were experiments or real life
Right.
kinds of applications. Maybe you could go through some of those.
We have two levels of validation that you probably found on our website. The first is third-party testing that we've done either at
Right.
AVL, those were simulations. At UTech in Detroit, we did actual test benching of the high voltage. It's a class, it's probably, that one's a class 6 through 8.
Yeah. Delivery truck.
Delivery, like an F-59 UPS truck style.
Right. Yeah.
And then we have some on-road validation in Europe with our smaller 100-volt drive. And now we've just launched our first bus, and we have our first UPS trucks for our partners, C Electric, and an axle with Linamar that are being upfitted right now. Linamar's will be first quarter. C Electrics will hit the test tracks this month. And our electric bus is already on the road, and we're moving to first orders with them. So we've got a couple of really great on-road proof points as well that really show that ability to electronically gear, like to drive. I like to say I'm not as technical as you, Eric. So I just say I like to conquer real world driving. So be more efficient in the real world, not just your Sunday drive going to pick up groceries, but you want to be a truck that's loaded up with packages, or you want to cruise the highway and climb hills. That's where the coil driver is going to shine.
Yeah. And I mean,
this is the kind of stuff that I'm very, very interested in. So anyway, you were going to say something, Eric, and I cut you off. I'm sorry.
No worries. I was going to say, actually, a point about fuel cells. It's interesting that you bring that up. Because I've been doing a lot of thinking about powertrains and what's the the best way to do it. And it's like battery electric, I think, works really well for personal transportation. But you get to a point, and I kind of look at it from a fuel tank perspective, right? Like the average passenger car, you fill your tank up like once every couple of weeks, sort of thing. Whereas if you go into a working vehicle, all of a sudden you might be filling your gas tank up once a day or twice a day, right? And that directly translates to how much work the vehicle is doing, right? So a battery will easily do the passenger car type applications anywhere where you can get away with filling your tank up maybe once a week or once a day kind of thing. But as you get into heavy duty work, like a train hauling freight across the country, for example, or Class A trucks, long haul trucking and stuff like that, you get into a very, very different. You've got hundreds and hundreds of gallons of diesel oil that these things are burning as they drive down the road, and then all of a sudden, you need more energy density, and that's where I think hydrogen will play a big role.
Well, I'm also getting on board with hydrogen. Up until I found out about white hydrogen and some poor characters in Africa that discovered it by accident and unfortunately didn't survive. Now that we know that hydrogen is like every other gas embedded in the earth somewhere, it sounds to me like maybe that would be a better way for extraction as opposed to screwing around with hydrolysis or anything else like that. So I'm getting more and more enthusiastic about hydrogen. I know there's tons of it around. It's the number one element on the planet. But I'd really like to see is a cool way of reducing the cost for that stuff. And maybe the white hydrogen idea is a deal that could make things happen. And by the way, that guy that I was talking about, he was running a taxi cab, and that might be another application. I never really thought of it until you thought about usage and stuff like that. But taxi cabs, really, they don't stop much. Usually they run 24 hours a day. This guy was over-the-top Uber driver, but maybe there should be a special car or a special vehicle that would where a fuel cell might be useful. Swapping out cells is a lot faster and easier than sitting around charging up batteries. And like I say, again, you get depletion, or you get wear if you cycle them as much as maybe what a taxi driver would do. So maybe there's an opportunity out there for a new type of vehicle that would be for, taxi style transportation.
Yeah, I mean, you'd have to look at the actual mileage. I mean, taxis. I don't know how much time do they spend driving versus sitting around waiting. I'm not very familiar with the taxi industry really in that kind of depth. So I have no idea what's
No,
an
but
average
it would be
daily
interesting
mileage.
just from a high level.
Yeah.
Just from a high level, be interesting as far as the swap. The swap as far as if you think about taxis and how they could potentially charge wrong and degrade your battery just from wrong charging procedure.
Yeah.
That could be interesting.
Yeah. Well, actually, my father-in-law was a taxi driver, and he drove for 8 hours. And when he was done, he pulled into the shop and got out, and another guy got in, and away they went.
Yeah.
It was like a 24-hour kind of operation, or almost maybe 20 hours or something like that. But it was they were on the road all the time. A place like New York or whatever, I don't think those guys ever turn off the engine. I think they hot seat the vehicles. So there might be an opportunity then for a new type of vehicle that we haven't really looked at yet, and maybe your product with a fuel cell would be the right thing to do.
Yeah, it might be something to look at. That's for sure.
I mean, that's basically it's a duty cycle. That's the problem, right? I mean, if the vehicle is running 24 hours a day, if you have to charge for, say, 30 or 40% of that time, then that all of a sudden, what that translates to is essentially, 40% of vehicles to have the same operating, what is it? What's the word I'm looking for? Oh my God. Operating capacity, shall we say.
Yeah. And that's basically what we'll be looking at. So let me ask you, you mentioned that you have some stuff on buses and Lindemar and whatnot. Have you enticed any of the bigger OEMs in your direction yet?
We have. So it's still under NDA, so we haven't announced our name, but we have, what would have been a past big three global automotive passenger vehicle. Us actually with the desire to have an innovation project that could demonstrate kind of everything the coil driver does, the constant power, reduce rare earth dependency. And so Eric's been kind of taking the lead and working through that. We're working through some gates with them, but we're feeling pretty positive, and we've definitely learned a lot about what our coil driver is capable of, and they've learned a lot about kind of challenging the status quo, because that's part of it too, Sandy, right? It's a pretty You've been in this industry a long time, so it's a pretty traditional industry, and so we're really challenged on many different levels how you think about energy consumption.
Yeah. Well, as far as I'm concerned, I'm hoping I know which one it is, because one of the traditional OEMs has kind of like led the way on pretty much everything, and I'm hoping it's that group. But we won't discuss that here. Anyhow.
It's been a good partnership so far, so we're happy with it.
Yeah. So let me ask you the big question. If I take a traditional vehicle and I swap out what they have traditionally done and I put your system in, is there a cost advantage or a cost disadvantage?
So it depends on how you look at it.
The ABL study.
Yeah. So the driver is obviously going to be more expensive. But so if you look at it from a system level perspective, right? So you've got more money in the power electronics, but that allows you to wipe out the rare earth magnets in an electric motor. Let's say by going to an induction machine. And I mean, when you look at the price of rare earths, especially if you want to see some crazy numbers, look at the DOE critical materials report for 2023. They all sort of start saying like neodymium, dysprosium. These are all very, very supply risk materials for the medium and far term for clean energy type applications, right? So if we can get rid of those materials, I mean, even if we just ignore the environmental impact of refining rare earths is another.
Yeah, that's the big problem.
It makes a huge mess. But so needless to say that eliminating these expensive rare earths out of the machine essentially offsets the cost of the drive.
So depending on the end usage, I'd say in commercial trucking, which is where we've done and focused a lot of work so far, you're going to see up to 20% cost savings on the system, and that's an ideal system efficiency. So they're eliminating a 2-speed gearbox, using a battery.
That's still with a PM motor.
That's still with a PM motor.
Yeah.
And so that one, we've validated those price points through all the projects that we have, and we're really confident in our ability to take down the cost of a commercial truck substantially.
Yeah.
On passenger vehicle, it's slightly less because you're not going to have all the mechanical driven components that you have in a commercial truck, but I would say it's still in that kind of 10 to 12% system savings on the overall cost of the vehicle. So the battery, like you said, would save about $700 on an electric vehicle on the road today, just from battery savings.
Well, that's pretty good. But it sounds to me like where the real savings are for the consumer. It sounds to me like as a consumer, I probably wind up spending less money per year on electricity, and I'd probably get longer range, and I'd probably get a lighter vehicle, which again would equate to range, among other things. So is that part of your business plan then, or?
Absolutely, it is 100%. We're basically a business to business model, but the actual savings is at that end user, at that consumer user, whether that's you or I driving an electric vehicle, or a fleet that's driving, to drive down cost on their entire fleet, as fleet regulations come in prior to passenger vehicle regulations.
Well, we've done a lot of work with fleets and companies that manufacture Class A trucks for fleets. And those folks, they are very astute when it comes to total accounted cost. And total accounted cost means, how much is this thing going to cost me? And usually the cheapest part of the whole the whole procedure is buying the initial truck. Regardless of how much you pay for it, the total accounted cost over a year is vastly bigger than vastly greater than the original cost of the truck. And that's why only, if you look at trucks, very few truck companies will pick a cheap powertrain. Not interested. They will spend the best money they can get, or the biggest money they can get, on the powertrain that they know will give them $1 million. And that's what they look at. It's 1 million miles on a truck before you need to scrap it out and do something else.
Yeah. So, not only that, but like a breakdown. I can imagine a truck breaking down on the road somewhere. I mean, the cost of, especially if you've got perishable goods or something in there,
right?
The cost of that offsets any savings you might have done by buying a cheap drivetrain.
Exactly.
Single failure, right?
Yeah. So this sounds like, to me, I can see it in 3 different areas. One is heavy truck, and not with batteries, but probably with fuel cells. And then looking at the general consumer, dropping away from PM magnets and moving toward induction motors. And then that seems like a good idea. Most people don't need to have a race car. Very few grandmas want to go 0 to 60 in a couple of seconds. It doesn't happen. And most people use their car to go to the drugstore or the grocery store. They're not going to drive, from their home in Detroit to San Diego. It just isn't going to happen it hasn't happened very often. And I hear all this stuff about, well, I got to buy a truck because once every 2 years I tow a boat. Here, there's these guys down the road. They rent trucks. You could use one of those instead of hauling around this great big giant whatever. And then the last one is the one that I haven't really thought about at all before, which is the development of a taxi that could run on hydrogen, like a fuel cell, and with an incredible duty cycle. That strikes me as being, at least for me, one of the high points of this conference. Actually, the whole thing was quite good. I wasn't exactly sure what I was going to hit because, like I told my guys, gee, this sounds like magic, and Magic and I don't get along. I've been burned quite a number of times.
It's electron. So we're big on
reality.
Again, we're challenging and we know that, but it's based on physics. It's just taking physics of electric motors into electronics. It's a natural progression. But hey, Sandy, one thing I do want to say is even on the commercial truck, I'll say I'm a little bit different than you are, Eric, in that I do think there's a good place for full battery electric commercial trucks.
There is.
In
short haul.
Yeah, exactly. The shorter haul, the mid duty, that class 3 through 6. And there's a lot of problems there right now, from a total cost of ownership, I'm sure you're aware.
Well, even on class 8, if you want to have an experience, go down to Oxnard docks, and that's where Nikola is trying out their battery electric vehicles. Short haul, you've got a couple of great big giant freighters that you've got to unload and stuff like that. You have a look at that, and you see huge amounts of smoke, no smoke. I mean, and that's all. I mean, it's hot. Yeah. It's hot in California during the day, and these guys have got to run the AC system. But sure. I mean, at the end of the day, all they do is stand there and pollute. I'm not 100% into being a tree hugger, but at the end of the day, this is just plain old stupid. What happens in that neighborhood? I mean, everything around it's black. I mean, where did that come from? Well, it wasn't from a forest fire or something. This is coming from these big trucks spewing diesel exhaust. So this is the perfect application for battery. You can skip the fuel cell for that. Long haul, I'm a big fan of fuel cells, but for this other application where you're unloading trucks and it's really a short haul, but it's a big truck, like what Nikola is doing with theirs is. And I drove that truck. I drove it, and I didn't even know I had a trailer on back. I thought, I don't know, lost my mind. But I got in and drove the thing around, and then the guy says, "Oh, you might want to ease up a bit going around this curve." Really? Why? And then I drove it in and stopped it, and he said, "Well, you handle it really well." I was a little nervous with the trailer and whatnot when you were going around. What? I had a trailer? And then I got out and I thought I was going to faint. I mean, but with the power that you've got with electric, no shifting of gears and other, it's amazing what you can do. And quite frankly, I think any dockyard should, they should only allow, I mean, the cities could regulate that. Yeah. The dockyard in the cities could say, forget it. You can't bring a diesel in here. And that would be the end of that. And probably a lot of people in the neighborhood would be a lot happier as well.
Yeah, kind of like you said at the beginning, right? I think in general, media is not doing a very good job of telling the right story, because with electrification, there is some application that just makes absolute sense right now.
Yeah. Well,
the problem I have with a lot of the media stuff is they just get it sometimes so hilariously wrong.
No, we can't talk bad about media right now.
Oh, really? Well, I can. And I do. So there you are. I personally think that if you're not paying the ransom, like buying ads, you get thrown under the bus. And that's just the way it works. And these guys, if it bleeds, it reads. And hey, if we have to make up a story here and there, well, it's okay. But between marketing, I can't really divulge everything that I talk about either, but marketing, the range anxiety thing, and biodiesel is better than, is less polluting than going with, solar or whatever, on and on and on. Those things all came from marketing agencies. That didn't come from reality, and certainly didn't come from anybody who's an engineer. It's just, yeah, and it catches on. Sound bites really work well for at least for the medias, the different media groups. So,
yeah, I mean, when even biodiesel is one of those things. It's like, yeah, it works in a small setting, but you try to replace, let's say, the United States' diesel consumption with biodiesel, and you do the numbers on that. It's just like, where's it all going to come from?
Yeah, well, that wasn't really part of the discussion, I'm sure, at that large German company that we can't talk about. Anyhow, at the end of the day, this has been a lot of fun, and I've learned quite a bit, and I really am intrigued. I was kind of worried that either I would run out of intelligence in asking questions, or this was going to be so deep that I wouldn't really understand anything that's going on. But I think you explained it really quite well. And I think that the audience is going to kind of get into this. I'm hoping, too, that we do get quite a few bigger companies into this. And I'm hoping that some of them will look at this and say, you know what, this might be a better route to take than just abandoning ship and we're just going to stay making ICE vehicles because that's what Wall Street wants us to do. That's what I'm hoping will happen. A little bit will happen here for you.
Yeah, we're big believers that, well, the narrative being pushed right now is that it's slow. It is slow. That's true. But disruption happens through hard reality.
Well,
so it's going to take.
If you've got the media spewing out propaganda continuously about how this don't work and that don't work and we can't do this and let's get back to basics and whatnot. Well, you keep doing that. Plus, you got the political thing going on. I'm pretty sure that sooner or later, the general public will get enough education to figure out that, hey, this guy's lying to me and so is that guy. And then maybe things will happen. And then, of course, that it's come to fruition when you hear somebody who is dead set against EVs and everything else, and they come along and say, oh, yeah, well, when I blah, 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 and I told everybody. Yeah, that's when you know that the tide has turned. Yeah. Yeah. But anyways, it's been great talking to you. I really appreciate you guys coming on. And I also very appreciative to Farsad for letting us use this fabulous recording area here. I'm extremely excited about running back. I'm sure Eric is extremely excited about running back and telling Cheryl, our CFO, that he has to buy more stuff. Yeah. Well, we have to be like Farsad. Yeah.
Thank you very much for having us on the show. We really, really appreciate it. And we invite you to come on out and drive our electric Humvee and feel for yourself the coil driver.
Oh, really? Well, I would love to do that. Where are you guys located anyways? I didn't see that.
We're sitting in Phoenix, just outside of Phoenix, Arizona.
Outside of Phoenix. Ah, okay.
That's where our Humvee lives. So you can kind of take it for a drive, and Eric would be happy to take it out with you and kind of let you feel.
Yeah.
Well, we might just take you up on that. A ride and drive. I'm not sure whether I don't know where I'm going to be next week, let alone when I'm going to be in a certain location. But it would be great to try that out. I think I'd enjoy trying to do that.
Yeah, I think you would too. Anytime, Sam. Okay.
Because that talk curve is also quite fun. Because we've only talked about the the serious business stuff, efficiency and cost and blah blah blah. But
yeah.
Following that torque curve is it's like a 2-speed, right? You do feel it when you
Wow.
floor and you follow that curve. It's like, it hauls like a freight train, lets off a little bit, and then it's like warp drive as you hit parallel mode. It's
Really?
yeah,
Wow.
it's fun.
That sounds like even more fun. And there's a lot of desert around Phoenix.
There is
So
a lot
I
of
can't
desert.
possibly hurt it. Yeah.
Oh,
So
Good
yeah.
deal.
if you like to drive, it's definitely a fun afternoon.
Cool.
All right.
I'm looking for fun. Yeah. Okay. Well, thanks very much, Susan and Eric. Thank you so much for attending our podcast. And we'll be putting your website so people can see what's going on. That'll be coming up. And to all those who've watched or listened, thank you very much for listening to Munro Live podcast again. Thank you. Bye now.
Thank
Thank
you.
you.